fourth classification of signal is even and odd signals. Sometimes even signals we call it as a symmetric signals, and odd signals we call it as anti-symmetric signals. A signal x of t is referred to as an even signal if x of minus t equal to x of t. The even signal is also called symmetric signal as it has a symmetry with respect to the vertical axis. That is, the signal for t less than 0 is the mirror image of the signal for t greater than 0. T greater than 0 is the positive signal and t less than 0 is the negative signal. This signal for t less than 0 is the mirror image of the signal for t greater than 0. Example, x of t equal to a cos omega t. A is the amplitude of the signal, cos of omega t. Suppose when t less than 0 means negative sign, negative value aitu andre minus t. Then cos of minus omega t equal to plus cos omega t. So we know the formula cos of minus theta equal to plus cos theta, like that. ಸೊ ನೆಗೆಟಿವ್ ಸೈನ್ ಹಾಕಿದ್ರು ಕೂಡ ಕಾಸ್ ಏನಾಗುತ್ತೆ ಪಾಸಿಟಿವ್ ಅಲ್ಲೇ ಬರುತ್ತೆ, ಗೊತ್ತಾಯ್ತಲ್ಲ. ಸೊ ದೇರ್ ಫೋರ್ cosine is the even signal. Cosine wave is the even signal. A signal x of t is referred to as odd signal if x of minus t equal to minus x of t. ಸೊ ಇವಾಗ ಸಪೋಸ್ ಟಿ ವ್ಯಾಲ್ಯೂ ಈಸ್ ನೆಗೆಟಿವ್ ಅಂತ ಅಂದರೆ ಟಿ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 0. ಸೊ ರಿಸಲ್ಟ್ ಬಿಕಮ್ಸ್ ನೆಗೆಟಿವ್ ಆಫ್ ದಿ ವ್ಯಾಲ್ಯೂ ಅಂದರೆ ಎಕ್ಸ್ ಆಫ್ ಮೈನಸ್ ಟಿ. ಸೊ ದೆನ್ ರಿಸಲ್ಟ್ ಬಿಕಮ್ಸ್ ಮೈನಸ್ ಎಕ್ಸ್ ಆಫ್ ಟಿ ಅಂತ ಹೇಳಿದ್ರೆ ದಟ್ ಸಿಗ್ನಲ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಆಡ್ ಸಿಗ್ನಲ್ ಆರ್ ಆಂಟಿಸಿಮೆಟ್ರಿಕ್ ಸಿಗ್ನಲ್. The odd signal is antisymmetric with respect to the vertical axis as shown in the figure. Example, an antisymmetric signal is A sin omega t. A is the amplitude of the signal, sine wave, this is the sine wave, omega t. Omega is the angular frequency, t is in time. So if t is greater than 0, positive, so sine of omega t will be sine omega t only. If t is less than 0, means t value negative bantu anta heladre, sine of minus omega t equal to minus sine omega t. We know the formula sine of minus theta equal to minus sine theta. So therefore sine wave is the odd signal. Any signal x of t can be expressed as a sum of even and odd components. That is, x of t equal to xc of t plus x naught of t. This x of t is sum of the even and odd components of the signal. Call it as equation number 1, where xc of t is even component of the signal and x naught of is the odd component of the signal. Replacing t by minus t in equation number 1. Equation number 1 ಗೆ t ಇರೋ ಪ್ಲೇಸಲ್ಲಿ ಮೈನಸ್ ಸೈನ್ ಮೈನಸ್ ಟಿ ಅಂತ ರೀಪ್ಲೇಸ್ ಮಾಡಿ, t becomes minus t. So x of minus t equal to xc of minus t plus x naught of minus t. Okay, x of minus t equal to, this is even signal, so therefore xc of minus t will be xc of t only. This is odd signal, x naught of minus t will be minus of x naught of t. Call it as equation number 2. Adding equation number 1 and equation number 2, add these two equations. So x of t plus x of minus t equal to 2 times of xc of t. Here plus x naught of t and minus x naught of t cancel out. So we'll get xc of t equal to 1 upon 2 x of t plus x of minus t. Call it as equation number 3. Similarly, subtracting equation number 2 from equation number 1, we obtain, so subtract equation number 1, equation number 2 from equation number 1, x of t minus x of minus t equal to xe of t minus xe of t cancel out, x naught of t minus of minus is plus x naught of t. So it is 2 times of x naught of t. So 2 times of x naught of t equal to x of t minus x of minus t. Then cross multiply, x naught of t equal to 1 upon 2 into x of t minus x of minus t. Call it as equation number 4. Similarly, the even and odd parts of a signal x of n can be obtained using the following relations. Suppose dt signal consider ಮಾಡೋದಾದ್ರೆ x naught of n equal to half of x of n minus x of minus n. This is CT signal, continuous time signal, and this one is the discrete time signal. N is the index or integer, t is in time. Fifth classification of signal is energy and power signal. Consider a voltage V of t across a resistance R producing a current I of t. Here V of t and I of t are instantaneous of the amplitudes. The instantaneous power dissipated in the resistance R is defined by P of t equal to product of V of t into I of t. V of t as it is, we know the formula by Ohm's law. I of t becomes V of t by R. So V of t into V of t is V square of t divided by R. Call it as 1. Or P of t equal to, we know the Ohm's law, V of t equal to I of t into R. So here I of t into I of t is I square of t into R. Call it as equation number 2. For a resistance of 1 ohm in each equation, equation number 1 and 2, shows that the instantaneous power P of t is equal to the square of the amplitude of the signal. Suppose ಇವಾಗ R resistance 1 ohm andre instantaneous power P of t will be square of the amplitude. Here also these are the equation number 1 and 2 ಏನಾಗುತ್ತೆ, resistance equal to 1 ohm andre instantaneous power of P of t will be square of the amplitude of the signal. Next, integrating equation number 2 over the interval mod of t less than or equal to capital T, we can express the total energy and average power of a signal as E equal to limit t tends to infinity integral of minus t to t I square of t into dt. We know the energy formula. Energy is nothing but product of power and time. So product of power and time. So here power becomes I square of t into R. If R equal to 1 ohm, then I square of t into t only. So take integration and limitation ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ dt ಬರುತ್ತೆ. E equal to limit t tends to infinity integral of minus t to t I square of t into dt. Energy unit is joules. So if R equal to 1 ohm, call it as 3. Then average power P equal to limit t tends to infinity 1 over 2t. So this is average power integral of minus t to t I square of t into dt. Like one sine wave ಅಲ್ಲಿ average consider ಮಾಡಬೇಕು. So power unit is watts. Call it as equation number 4. For any signal x of t, the total energy is defined as E equal to limit t tends to infinity integral of minus t to t absolute value of or mod of x of t square dt energy unit becomes joules. Call it as equation number 5. And the average power is defined as P equal to limit t tends to infinity 1 upon 2t integral of minus t to t mod of x of t whole square dt. Power unit is watts. Call it as equation number 6. The square root of P is known as RMS value of the signal x of t. Root means square value. That square root of P, we call it as RMS value. RMS is nothing but maximum by root 2. Value of the signal x of t. For a dt signal or discrete time signal x of n, the energy E is defined as E equal to summation of n equal to minus infinity to infinity mod of x of n square whole square. Call it as equation number 7. This is for dt signal energy. Energy for dt signal. The average power of a discrete time signal x of n is defined as power p equal to limit n tends to infinity 1 upon 2n plus 1 summation of n equal to minus n to n mod of x of n whole square. Call it as equation number 8. A signal is an energy signal if and only if the total energy of the signal is finite. For an energy signal, power becomes 0. Similarly, the signal is said to be power signal if the average power of the signal is finite. For a power signal, energy becomes infinity. The signal that does not satisfy above properties are neither energy nor power signal. Definition for energy and power signal. A signal x of t is called an energy signal if the energy satisfies energy vary from 0 to infinity. For an energy signal, power becomes 0. A signal x of t is called a power signal if the power satisfies power vary from 0 to infinity. For a power signal, energy becomes infinity. Classification. Sixth classification of signal is causal and non-causal signals. A continuous time signal x of t is said to be causal if x of t equal to 0 for t less than 0. Otherwise the signal is non-causal. ಅಂದರೆ ಕಂಟಿನ್ಯೂಸ್ ಟೈಮ್ ಸಿಗ್ನಲಲ್ಲಿ ಎಕ್ಸ್ ಆಫ್ ಟಿ ವ್ಯಾಲ್ಯೂ ಬಿಕಮ್ 0 ವೆನ್ ಅಂತ ಹೇಳಿದ್ರೆ ವೆನ್ ಟಿ ಇಸ್ ಲೆಸ್ ದಾನ್ 0 ಮೀನ್ಸ್ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಬಂತು ಅಂದರೆ ಔಟ್ಪುಟ್ ಬಿಕಮ್ 0 ಆಗಬೇಕು. ಸೊ ದೆನ್ ದಟ್ ಸಿಗ್ನಲ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಕ್ಯಾಶುಯಲ್ ಸಿಗ್ನಲ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಕಾಶುಯಲ್ ಸಿಗ್ನಲ್ ಅಂತ. ಸೊ ಅದರ್ವೈಸ್ ಗ್ರೇಟರ್ ದಾನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಏನಾದರೂ ಇದ್ದರೆ, ಸೊ ಅದರ್ವೈಸ್ ನಾನ್ ಕ್ಯಾಶುಯಲ್ ಸಿಗ್ನಲ್. For an anti-causal CT signal, x of t equal to 0 for t greater than 0. T greater than 0 means when t is greater than 0, positive ಅಲ್ಲಿ ಇರಬೇಕಾದ್ರೆ x of t equal to 0 ಬಂದಿದ್ರೆ that signal we call it as anti-causal CT signal, continuous time signal ಅಂತ ಕಾಲ್ ಮಾಡ್ತೇವೆ. Similarly, for a DT signal, x of n is said to be causal if x of n equal to 0 for n less than 0. ಅಂದರೆ ಇಂಡೆಕ್ಸ್ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂಸ್ನಲ್ಲಿ ಔಟ್ಪುಟ್ ಏನಾಗುತ್ತೆ ನಿಮಗೆ 0 ಬಂದಿದ್ರೆ, ಸೊ ದಟ್ ಈಸ್ ಕ್ಯಾಶುಯಲ್ ಸಿಗ್ನಲ್ ಆಗುತ್ತೆ. ಅದರ್ವೈಸ್ ದಿ ಸಿಗ್ನಲ್ ಈಸ್ ನಾನ್ ಕ್ಯಾಶುಯಲ್ ಸಿಗ್ನಲ್. ಫಾರ್ ಆ್ಯಂಟಿ ಕ್ಯಾಶುಯಲ್ ಡಿಸ್ಕ್ರೀಟ್ ಟೈಮ್ ಸಿಗ್ನಲ್ ಏನಾಗುತ್ತೆ, ಎಕ್ಸ್ ಆಫ್ ಎನ್ ಈಕ್ವಲ್ ಟು 0 ಫಾರ್ ಎನ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0. ಎನ್ ವ್ಯಾಲ್ಯೂ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0 ಇರಬೇಕಾದ್ರೆ ಔಟ್ಪುಟ್ ಬಿಕಮ್ 0. ದಟ್ ಈಸ್ ಆ್ಯಂಟಿ ಕ್ಯಾಶುಯಲ್ ಡಿಸ್ಕ್ರೀಟ್ ಟೈಮ್ ಸಿಗ್ನಲ್.